Hello again, class. This is the third part of the AP Stats Combined FRQ review. And we'll start with number 5 from 2019. A company that manufactures smartphones developed a new battery that has a longer lifespan than a traditional battery. From the date of purchase of a smartphone, the distribution of the lifespan of the new battery is approximately normal with a mean of 30 months and a standard deviation 8 months. For the price of $50, the company offers a 2-year warranty on the new battery for customers who purchase a smartphone. The warranty guarantees that the smartphone will be replaced at no cost to the customer if the battery no longer works within 24 months from the date of purchase. Part A, in how many months from the date of purchase is it expected that 25% of the batteries will no longer work? Justify your answer. So this basically we want to know, imagine a normal curve, and we want to know this area, which is 0.25. We want to know what's the z for that value, and then later on, what's the x for that value. All right. So to do that, we need to use our table. I'm going to erase all this so it doesn't get in the way, but you got the visual. X is the lifespan of the battery in months. Mean is 30. Standard deviation is 8. So an area to the left of 0.25 corresponds with that z-score of negative 0.6745. And you can use the table. You can use inverse norm with an area to the left of 0.25. So now you're going to put that into your z-score formula. Negative 0.6745 equals the x you are solving for. You're unstandardizing the z-score. X minus 30 over 8. And it turns out that x is 24.6 months. You could also have used inverse norm in your calculator to get the number. 0.25 is the area to the left. 30 is the mean. 8 is the standard deviation. Put that in your TI and you get 24.6 months. Part B, suppose one customer who purchases a warranty is selected at random. What is the probability that the customer selected will require replacement within 24 months from the date of purchase because the battery no longer works? So this is basically a garden variety normal probability calculation where x is less than 24. You know that the mean is 30, the standard deviation is 8, so the corresponding z-score is negative 6 over 8 or negative 0.75. Convert that to an area or probability, and you see that the answer is 0.2266. So you could have used normal CDF with negative E99 as the leftmost limit, 24 is the rightmost, 30 is the mean, 8 is the standard deviation, gives you a probability of 0.2266. Part C, the company has a gain of $50 for each customer who purchases a warranty but doesn't require a replacement. The company has a loss of $150 for each customer who purchases a warranty and does require a replacement. What's the expected value of the gain for the company for each warranty purchase? So here's your probability table. For a loss of $150, that probability we calculated in Part B is 0.2266. The other possible outcome is $50 gain for the company. So people that purchase a warranty but their battery is fine, that's 1 minus 0.2266, which is basically everything else. So you're basically going to calculate the expected value by multiplying each gain times the corresponding probability. So $50 times 0.7734 minus $150 times 0.2266 yields an expected gain per warranty purchase of $4.68. So that's a long run average. Number 5 from 2012, a recent report stated that less than 35% of the adult residents in a certain city will be able to pass a physical fitness test. Consequently, the city's rec department is trying to convince the city council to fund more physical fitness programs. The council is facing budget constraints and is skeptical of the report. The council will fund more physical fitness programs only if the rec department can provide convincing evidence that the report is true. So the rec department plans to collect data from a sample of 185 adult residents in the city. A test of significance will be conducted at a significance level of alpha equals 0.05 for the following hypotheses. The null is p equals 0.35. The alternative is p is less than 0.35, where p is the proportion of adult residents in the city who are able to pass a physical fitness test. Part A, describe what a type 2 error would be in the context of the study and describe what the consequence is of making this type of error. So type 2 error is when you fail to reject the null when the alternative is actually true. So in this case, it means you do not have enough evidence that less than 35% of city residents can pass a physical fitness test, when in actuality, less than 35% actually can. So what this means is the council will not fund the program, even though they probably should, because the smaller proportion of residents are actually fit compared to what the city council would like. So that's a type 2 error. It's a false negative. You think that things are fine when it turns out they're really not. B, the rec department recruits 185 adult residents to volunteer to take the physical fitness test. The test is passed by 77 of the 185 volunteers, resulting in a p-value of 0.97 for the hypothesis stated above. If it was reasonable to conduct a test of significance for the hypothesis stated above using the data collected from the 185 volunteers, what would the p-value of 0.97 lead you to conclude? So this is a problem that you can do without a calculator, which might be a type of thing you could see on this year's AP test because they say you don't need a calculator. So they basically give you the numbers and they want you to describe what the numbers mean. So the p-value of 0.97 is much higher than 0.05. In fact, it's so high that you'd probably double check the numbers just to make sure they're right. But here they gave you the p-value. So we fail to reject the null. There is little evidence that the proportion of city residents that would pass a physical fitness test is less than 35%. But that makes sense since p hat is already on the wrong side of 0.35. So you know that just on its face, the p-value is going to be really, really high because the p hat's not even in the direction of the alternative. You want an alternative that's less than 0.35, but your actual sample proportion is well higher than 0.35. Part C, describe the primary flaw in the study described in Part B and explain why it's a concern. So it's pretty clear you had volunteers. People that are going to volunteer for a physical fitness test are probably more likely to pass it because why would you take a test if you think you're going to fail? They probably feel like they're in pretty good shape. They feel pretty good about themselves. They want to prove to themselves and others that they are physically fit. So the proportion of volunteers that are physically fit is probably higher than the actual proportion of city residents that are physically fit. So the sample proportion is very likely an overestimation compared to the true proportion of city residents that are physically fit, which might actually be closer to 0.35 or less. 2010B number 2. In response to nutrition concerns raised last year about food served in school cafeterias, the Smallville School District entered into a one-year contract with the Healthy Alternative Meals Company. Under this contract, the company plans and prepares meals for 2,500 elementary, middle, and high school students with a focus on good nutrition. The school administration would like to survey the students in the district to estimate the proportion of students who are satisfied with the food under this contract. 2 sampling plans for selecting students to be surveyed are under consideration by the administration. One plan is to take a simple random sample of students in the district and then survey those students. The other plan is to take a stratified random sample of students in the district and then survey those students. Part A, describe a simple random sampling procedure that the administrators could use to select 200 students from the 2,500 students in the district. So you can go many different ways with this. You can use a computer generator, you can use a random number table. Basically, whenever they ask you to describe something, just don't use a random number table, just use a computer generator. So each of the 2,500 students is first assigned a number from 1 to 2,500. So remember, the first step is to assign or label each participant, potential participant. Then you can use a random number generator to pick 200 unique or non-repeating numbers from 1 to 2,500. Those 200 numbers selected will be chosen to take the survey. Another possibility is to use a random number table. Again, a random number table just makes it more complicated. Use a computer generator, but again, make sure you assign numbers to the subjects. Part B, if a stratified random sampling procedure is used, give one example of an effective variable on which to stratify in the survey. Explain your reasoning. So you can stratify by school level. And one reason you might want to do that is because maybe each student at each level has a difference of what it means to be nutritious or eat a nutritious diet. Elementary school students can pretty much eat anything, but by the time you're in high school, you have a pretty good idea of what's healthy and what's not. You still eat the unhealthy stuff anyway, but at least you know. So you could stratify by the school level, elementary, middle, and high school, and then randomly pick people from each level. Part C, describe one statistical advantage of using a stratified random sample over a simple random sample in the context of this study. So if each school level has differences in what they value, in terms of nutrition, having a proportional representation obtained through a stratified sample may provide a more accurate estimate of the proportion of students compared to a simple random sample. So when you can stratify on some variable that you know might actually affect the results, and you can do it, go ahead and stratify. So that's one big statistical advantage. Another advantage is that the stratified sample also guarantees representation of every school level, whereas in an SRS, theoretically, you could get all students that are from elementary schools or high schools or middle schools. Very unlikely, but what a stratified sample does, it guarantees a proportional representation based on the level of school. Finally, 2018 number 4, the ACL is one of the ligaments that help stabilize the knee. Surgery is often recommended if the ACL is completely torn and recovery time from the surgery is lengthy. A medical center developed a new surgical procedure designed to reduce the average recovery time from the surgery. To test the effectiveness of this new procedure, a study was conducted in which 210 patients needing a surgery to repair a torn ACL were randomly assigned to receive either the standard or the new procedure. Part A, based on the design of the study, would a statistically significant result allow the medical center to conclude that the new procedure causes a reduction in recovery time compared to the standard procedure for patients similar to those in the study? Explain your answer. And the answer is yes. Subjects were randomly assigned to either the standard procedure or the new procedure. So that reduces the effect of confounding variables. It's a pretty good sample size, 210 subjects. So a statistically significant result would allow researchers to conclude that the new procedure causes a reduction in recovery time because you basically have a controlled, randomly assigned experiment. B, do the data provide convincing statistical evidence that those who receive the new procedure will have less recovery time from the surgery on average than those who receive the standard procedure for patients similar to those in the study? This is a two-sample t-test for mu1 minus mu2, where mu1 is the mean recovery time for patients getting the standard treatment, and mu2 is the mean recovery time for those getting the new treatment. The null hypothesis is mu1 equals mu2. In other words, that the mean recovery times are the same regardless of the treatment. The alternative is mu1 is greater than mu2 because we expect those patients getting the standard treatment to take longer to recover than those getting the new. That's what we hope for. So the alternative is mu1 greater than mu2. So we're going to check our conditions. First, the patients were randomly assigned. The normal condition, the sample size of 110 and 100 are both at least 30, so CLT applies and allows the approximation of normality for both groups. You don't need to check the independence condition because you have a randomly assigned experiment. So here's the value of t. T is equal to x bar 1 minus x bar 2 over the square root of s1 squared over n1 plus s2 squared over n2. Plug those numbers in, and they're all given to you. Comes out to a t statistic of 7.13 for 207.18 degrees of freedom. Don't forget the df. And the p-value is something very, very, very small, 8.35 times 10 to the negative 12th. So that's much less than 0.05. You reject the null in favor of the alternative. There's overwhelming evidence that the new procedure would have less recovery time than the old procedure on average for those patients similar to those in the study.